Hi there, it's Ajmer from In-House Solutions with another video in the What's New in 2026 series. So this is an existing file that I showed in Mastercam 2025 for equal depths, but it shows quite well with the additional functionality they've added to allow you to pick critical depths and OptiRough. So you can pick specific Z heights to actually force this thing to take a cut. You can manually pick it, or you can include flats. It'll find the flats automatically. And in here, you can see I picked the point at the top there and the point at the top there. All right. So again, just to kind of review what I did last time. So this is standard depth cuts. You can see it's going the standard 20 millimeter down and leaves a little bit of a cut. And then you have the uniform step downs where it slices the total depth into equal values. And in this one here, I've added critical depths. So this is standard step downs. So you can see it's 20, 20, 20, and it's taking a cut here. So then it goes to a shallower cut, and then it jumps back to 20. And then now it needs to take a shallower cut, so it goes to 15 here. And then again, it jumps to 20, and then tries to equalize out the 20. So it's trying to add these in between full 20 millimeter cuts. And the next one here is uniform step down. So I'll just show you that as well. So this is enabled with the same 2 points picked. So it's trying to equalize the cuts now. So if I take a look at that one, you can see it's trying to equalize the cuts to get to the slice that we picked. And then it equalizes the cuts to the slice that we picked. And then it goes back to what it was before. So a really quick and easy way to force OptiRough to go to a certain Z height. And the next thing now they've added is the ability to do a tapered entry helix. And I'll show you what that is. So if you go to entry parameters here, or sorry, entry motion, there's an option for tapered helix. So in this example, I've got a 6 3/4 radius. So let's get into this one. So this is the uniform. So let's take a look at the helix here. So by standard default, it's going to give you a 6 3/4 rad when I backlog this thing. So when I kind of come up to here, you can see it's doing the radius of 6 3/4, nothing changes. And it goes all the way down. So one thing to note is it's a 16 millimeter tool. So if I look at the one with the tapered enabled, so this one here I've got tapered helix enabled. So now it looks at the size of the tool. So this is a 16 millimeter tool. And let me just click on the offset here. So now you can see here, there is a bit of a blurb there. It says top of the helix is 95% of the tool, and the bottom of the helix is 25% of the tool. And I drew some geometry in here just to kind of show you exactly what it does. And if I backlog this one, just click right there, just to kind of show you. And now it kind of comes in, and it's going to slowly get smaller until it gets to the bottom. So that is a tapered helix to aid in coolant flow and chip evacuation, doing deep pockets. So this one here doesn't really look at the entry motion, this number here. Now it looks at the tool diameter. So it starts at 95, ends at 25. So, you know, if you're figuring stuff out, that's how exactly it does it. All right, guys, talk soon.